Hello everyone. So this would be in the continuation of the previous video. So in this only, in this again you have to find the V naught expression. So at V naught at 0 plus, what you are having? At V naught at 0 plus you are having 0 voltage, and V naught at infinity you are having V voltage. So what is the order of the system? Again it's in second order, because you can't really say like this capacitor and both of the capacitor are having same current. You can't really say that. So it's an second order system. Now what is the damping? Is it critically damped or over damped? Because underdamped and undamped, it can't be overdamped, underdamped or undamped. It has to be critically damped or overdamped. So it is overdamped, right? Because you are not having the same, you are not having the pole at same value. Okay, both of the poles are not at same value, because if you apply nodal here, you will have different current here, different current here, and different current here. So these RC, this R is having different current, this C is having different current, and this C is having different current. So both three, like all three parameters will be in action. This R, and this C. So all three will be in action. So you can't really tell that both of them, both of the poles are at 1 by RC. You can't really say that. Okay, so you have two poles both at different points. So it will be an overdamped system. So the response would look something like this. Okay, so your V naught will go something like this. And coming to this one, here you have this ideal buffer with gain 1. Ideal buffer means there would be no current flowing through this. Okay, so current is 0 here. So here you can say both of the R and C are having same current. Here also you can say R and C are having same current. So at 1 by RC only we are having two poles, right? And there are no zeros. Like you can't really make this V output to be 0. At infinite frequency you can make this V out to be 0, but at infinite frequency it doesn't count. So here you can have two poles, that two at 1 by RC. Okay, so your expression can be something like this: K value and RCS plus 1. RCS plus 1 all square. So that's how your response would look like. So so both of the poles are at same point only. So now this in this one it's an critically damped system. Okay, so this is a critically damped system. Why? Because of buffer. Okay, because of buffer. Now they can ask you, how can you make this buffer? So you just simply use an op-amp and just make this. Like here you have some V, your V output would be only. So that's how you can make this buffer. Okay, and this is how your output would look like. Okay, so then they can ask you like which one is faster, this one or this one. So you can tell this is critically damped and this one is over damped. So which one is faster? Critical damped is faster than over damped. So that you can see. And regarding this, they can ask one more question. Let me write it and then explain you. Okay. So I have thought I will explain those questions in some other video later on. Okay. So that's it for the video. Okay. Thank you.